Have you ever looked up at the night sky and wondered where it all began? For centuries, humanity has stared into the cosmos, driven by an insatiable curiosity, from ancient astronomers charting the stars to the iconic images from the Hubble Space Telescope. Each step has brought us closer to understanding our universe. Today, we stand on the precipice of a new era of discovery, thanks to one of the most ambitious scientific instruments ever built, the James Webb Space Telescope. Launched on Christmas Day 2021, the JWST is humanity's new eye on the universe. A magnificent time machine designed to peer back to the dawn of creation. It's not just a successor to Hubble, it's a revolutionary leap forward. While Hubble showed us the universe in visible light, Webb is designed to see in the infrared. This allows it to cut through cosmic dust and capture the faint light from the very first stars and galaxies that formed over 13.5 billion years ago. The idea for a telescope this powerful was born in the 1990s, not long after Hubble's own triumphs. Scientists dreamed of a machine that could answer even deeper questions. What did the cosmic dawn look like? How did the first galaxies assemble themselves? The project was eventually named after James E. Webb, a NASA administrator from the Apollo era who championed science as a core part of space exploration. His name is a fitting tribute to the spirit of discovery that fuels this incredible mission. Building the James Webb Space Telescope was an extraordinary feat of engineering. Its most stunning feature is the primary mirror. At 6.5 meters wide, it's made of 18 hexagonal segments, each coated with a microscopically thin layer of pure gold. Why gold? Because it's exceptionally good at reflecting infrared light, which is exactly what Webb needs to see. These mirrors are made from beryllium, a metal that is both incredibly light and strong enough to withstand the brutal cold of deep space. Unlike Hubble, which orbits just above Earth, Webb is positioned about 1.5 million kilometers away, at a special spot in space called the second Lagrange point. To solve this, engineers designed a massive 5-layer sunshield the size of a tennis court. Each layer is made of a material called kapton and is thinner than a human hair. This incredible shield protects the telescope's sensitive instruments, keeping them at an unimaginably cold temperature of around -233 degrees Celsius. This extreme cold is absolutely essential for detecting the faint infrared heat signals from the edge of the universe. The journey to get this marvel into space was long and challenging. The project faced numerous delays and budget hurdles, with the final cost exceeding $10 billion. It's one of the most expensive scientific missions ever. A huge part of the challenge was that the telescope was too big to fit into any existing rocket. So, engineers designed it to fold up like a piece of high-tech origami and then unfold itself in space. This complex deployment involved over 300 single points of failure. If even one step went wrong, the entire mission could have been lost. So, when the Ariane 5 rocket blasted off from French Guiana on Christmas Day 2021, the entire world was watching, holding its breath. Over the next 29 days, Webb executed a flawless sequence of maneuvers, unfolding its sunshield, deploying its mirrors, and coming to life in the void of space. It was one of the most brilliant and nerve-wracking achievements in the history of space engineering. So, what makes Webb so powerful? Its ability to see in infrared light means it's essentially a time machine. Light from the most distant objects has traveled for billions of years to reach us. When Webb looks at these objects, it's not seeing them as they are today, but as they were shortly after the Big Bang. Its suite of instruments is a technological marvel. ANI-RCM, the near-infrared camera, takes those breathtakingly detailed pictures we've all seen. ANI-RSPEC, a spectrograph, breaks down light to analyze the chemical composition, temperature, and motion of stars and galaxies. The MIRI instrument looks at even longer infrared wavelengths to study cold, dusty regions where new stars and planets are being born. These tools work together to paint a complete picture of the cosmos, from the atmospheres of planets orbiting other stars to the formation of the very first galaxies. In July 2022, NASA released the first images from Webb, and they were nothing short of spectacular. The image known as Webb's first deep field revealed thousands of galaxies in a patch of sky no bigger than a grain of sand held at arm's length. Some of these galaxies existed over 13 billion years ago, their light just now reaching us. The detail was mind-blowing, far surpassing anything Hubble could achieve. Since then, Webb has continued to deliver one revolutionary discovery after another. It has peered into the heart of the Carina Nebula, revealing stellar nurseries hidden behind clouds of gas and dust. It has found some of the earliest galaxies ever observed, dating back to just 300 million years after the Big Bang, pushing the frontiers of our knowledge further than ever before. And its work isn't limited to the distant universe. Webb is also changing our understanding of exoplanets, planets outside our solar system. It has detected water, vapor, and carbon dioxide in the atmosphere of a gas giant named WASP-39b, a huge step forward in the search for habitable worlds. It has even given us stunning new views of planets in our own cosmic backyard, like Jupiter and Neptune, providing fresh insights into their weather and moons. While Webb's main goal is science, its discoveries touch on some of the deepest philosophical questions we can ask. By studying the atmospheres of distant worlds, It's helping us search for the building blocks of life, like water and methane. Are we alone in the universe? Webb is bringing us closer than ever to finding an answer. Every image it sends back not only expands our scientific knowledge, but also challenges us to think about our own place in the vastness of space. Of course, a mission this complex has its challenges. Unlike Hubble, which was serviced by astronauts, Webb is too far away for any repairs. Its systems must continue to operate perfectly for its entire mission, which is expected to last for at least a decade, hopefully longer. Engineers built it with redundancy to give it the best possible chance of a long and productive life. The future of astronomy is bright, with Webb leading the charge. Its findings will pave the way for future missions, like the planned Habitable Worlds Observatory, which will be specifically designed to search for Earth-like planets. By working alongside other observatories, both on the ground and in space, Webb is helping us create the most complete picture of the universe ever assembled. The James Webb Space Telescope is more than just a piece of technology. It is a monument to human ingenuity, perseverance, and our unyielding desire to explore. It's the result of decades of collaboration between thousands of scientists and engineers from all over the world. As it silently orbits a million miles from home, it continues to unravel the secrets of the cosmos, bringing us closer to answering those fundamental questions. Where did we come from, and how did it all begin? In looking out to the farthest reaches of space, Webb ultimately helps us look inward, reminding us that the quest for knowledge is what makes us human. Thanks for joining us on this journey to the beginning of time. If you were as amazed by the story of the Webb telescope as we are, don't forget to like this video and subscribe to our channel for more deep dives into the wonders of science and space. We'll see you in the next one.